Hello and welcome. Introduction. Now I'm starting a new series of videos on something called a scheduler. Now to kick off this series, I'd like to discuss first of all what is a scheduler. So the aim of this video is to look into what is a scheduler and how to implement a scheduler to execute a single task. Now, a scheduler is a piece of code or program that determines which task to be executed at a particular point in time. Now, a task here is basically a piece of code, a smaller piece of code that executes in a operating system or an OS. Now, I would like to think of a task as something similar to a C function. Now, I realize this may not be the most accurate description of a task, but that is the best I can think of at the moment. So if we just think of a task as a C function. Now, I like to use this particular diagram to describe the scheduler again. So let's assume this circle represents the scheduler, and we got a bunch of tasks to be executed. So we have here task 1, task 2, and task n. N can be any integer. So as mentioned earlier, the function of the scheduler is to determine which of these tasks to execute. So which task to execute. And then the second objective of the scheduler is to determine when to execute that particular task. Now, in order to achieve this second objective, the scheduler will require timing signals. Now, these timing signals we call them ticks, and basically ticks can be interrupt timing signals from the timer that reside in your microcontroller. Right? Now, the whole process here is very similar to a timetable. So here I have a very simple timetable. Monday 9 a.m. to 10 a.m. we have math scheduled, and then 10 a.m. to 11 a.m. nothing is scheduled, and then from 11 a.m. to 12 noon we have English, and then 12 noon to 1 p.m. nothing is scheduled, and then the following day, Tuesday, the only thing that is scheduled is physics. That is 10 a.m. to 11 a.m. Now, all these scheduling as to when to conduct the class or subjects derives the timing from a real-time clock. All right, so that's how I view as what a scheduler would look like. Now, there are basically two types of tasks. The first one is periodic tasks. Now, these tasks are performed, say, once every 200 milliseconds. That means every 200 milliseconds, the task will be executed. Then the second type of tasks is known as one-shot task. And these tasks are only executed or performed once after a delay of, let's say, 100 milliseconds. Now, let's take a look at this definition using this timing diagram. So here I have using two timers. Timer 2 is executing what we call earlier periodic task. So at the first 200 milliseconds, when it occurs, the task is executed. So this blue rectangle, represent a task. So at the next 200 milliseconds, it gets executed again. And then after another 200 milliseconds, it gets executed. The same task is executed again. So these are known as periodic tasks. Now, timer 1 is executing what we call a task once at time 100 milliseconds. So this is known as a one-shot tasks. Scheduling a single task. Now, how do you schedule a task? Now, one solution is to use what we call a timer-based solution. Now, in this particular method, we used a timer-based interrupt as a means of invoking or calling tasks or functions at particular times. And this involves using what we call interrupt service routines or ISRs. Okay, so before we go any further, let's take a quick look at the ATmega 328 internal interrupt. Now, I have previously explored the ATmega 328 interrupt system. You will find the details of that in video 61, where I talk about the ATmega 328 external interrupt, and then video 62 I looked into the ATmega 328 internal interrupt. Now in this video, that's video 62, there are more details regarding the internal interrupt. Now here I will just briefly look into it before we look at the code. Now, as the name internal interrupt, it tells us that the interrupt occurs inside the microcontroller. In this case, I'm going to use timer 0 to generate the interrupt. Now, let's assume that this blue box here represents the ATmega 328. So inside this 328, as mentioned earlier, is timer 0. All right. And here is the flash memory. In the flash memory, we have the what we call a main program stored. And now here, this is this portion here that is location 0000 hexa, or that's the bottom of the memory of the flash memory. And then at the top of the flash memory is 7FFF hexa. That is in decimal 32,767. All right, and then at location 0020 hexa is what we call, it stores the vector number 17. This is where it stores the internal the interrupt service routine address. All right, we'll come to that in a few moments. Now, let's explore this interrupt vector thing. Now, from the data sheet, this is the interrupt. So this is the interrupt vector we call table. As mentioned earlier, I'm only interested in vector number 17, which is this one here. Let's put a red dotted box around it. So vector number 17, the program address is 0020 hexa, as pointed out earlier. And then the name given to that is the timer 0 OVF, timer overflow flag. Now, remember this name. We'll come to this in a few moments. Now, okay, let's see what happens when an interrupt occurs. Now, assuming the timer 0 generates an interrupt signal or a tick, it would jump to location 0020 hexa. All right, so that is vector number 17 as seen from the datasheet. Now, at that location is the interrupt service routine address. All right. Now, the interrupt service routine will point to where the interrupt service routine or the task is stored. Now this is just a piece of code. All right, so the address will tell the CPU where to find the task or the ISR routine. And when that routine finishes or completed its task, it will then return the control back to the main program. Okay, so before we look at the code, let's take a look at the steps to program a single task. So the first thing, or one of the things you need to do is to set up the timer. Then you need to set up the interrupt for the interrupt service routine or the task. And then we set up the function and then send it into a forever loop. All right, so these are the steps to take. Now let's see. Okay, so the code. Now here's the beginning part of the main function of the code. So this should be familiar to most of the viewers here, so I'm not bothered to go into that. Here I've defined an LED label with the port D bit 3. All right, so port D bit 3, I'll call it LED. And then I have a variable called timer overflow count. This is of the type unsigned 8-bit. Then here the main function starts. We set the port D as an output. Then we set the variable initial value to 0. So timer overflow count will be 0 at the start. Then we set up the timer. Then we set up the timer counter control register, TCCR-A, to normal mode. And then we set the timer mode control register B, give it this value, 05 hexa, that is to select a prescaler of 1024. Then we set up the interrupt here. All right. And then we set the global interrupt. And here, this part here, we just set it into a endless loop or forever loop. So this is the main function. Okay, so let's take a look at the interrupt service routine or the task. So we start off with this ISR, uppercase, and then in brackets, we put timer 0 underscore OVF underscore small casing VECT. Now, this has to be exactly the same as this, and you'll recognize this from the early discussion taken up from the datasheet. All right, so it has to be exactly like this. If not, the thing won't work. And here we have the TC and T0. We clear it. All right, we clear the timer. Then we have the overflow flag, and we also clear the overflow flag. Then we check the overflow timer overflow counter variable for 76. And then here we flip the LED. If that means if it's 0, we change it to a 1. If it's a 1, we change it to a 0. And then we clear the counter, this timer overflow count, to 0. And then else, if it's not this, then we increment the variable by 1. So timer overflow count plus plus, that will increment the variable by 1. And basically, that's it. That's the task. The task basically is to blink an LED. So this is the timing diagram for the code that we have just discussed. So at every 1 second, the task would be executed. This rectangle blue boxes here represent the task, and it gets executed every 1 second. Hardware. Now, to test the code, we require some hardware. And here's the circuit diagram that is required. So I have an LED, all right, which is green color on the wiring diagram, and or any other color that you want to use. It doesn't have to be green. So one end of the LED, that this part here, the anode, is connected to pin 3 of the Arduino Uno board, and then the cathode of the LED is connected to a 220 ohm resistor, and the other end of the resistor is connected to ground, which is this part here. And basically this is the hardware setup to test the code. Code demonstration. Okay, so here is my AtMel Studio 7, and I've uploaded the code that we have discussed in detail earlier. So I'm just going to briefly just go through this with you before I actually try to upload and run the code. So here is the include directives and define directives, and here I have defined PD3, which is port D bit 3, with the label LED. So and then here is the main function of the program, and here is the statement that defined port D as an output. Here is a variable time overflow count, setting it at the initial, giving it initial value of 0, and here is the setting up of the timer. All right, so this one here will set the timer to 0, set the timer to normal mode, and a prescaler of 1024. Right, and then here is the setup of the timer interrupt, and set the global interrupt here, and basically it will then send the whole program or code into a endless loop, a forever loop. And here is our ISR, or interrupt service routine, with timer 0 OVF underscore VECT. All right, so this is the ISR, which is our task. And basically this first line here is to clear the timer, and then clear the overflow interrupt flag, and then check for the count for 76. 76 is because I want to have a delay of 1 second, and so if it's if this is true, then this one would flip the LED. In other words, if it's a 0, it would toggle it to a 1. If it's a 1, you toggle it to a 0, and then reset the timer. And then here, if it's not, then we increment the timer overflow count variable by 1. And so this would be the task or the interrupt service routine. Let me just try to bring up the camera to see the LED. All right, so and so here is my setup. So this is the green LED. All right, let me get a more my pen as a pointer. So this is the LED, and on this side here is the Arduino Uno. Let me just pan it across. So that, all right, so that is my Arduino Uno. Sorry, I have to do this manually. All right, and here, let me just put my camera down. And all right, okay. So let me just now upload the code. So, and the code is uploaded. As you can see, the LED now is blinking at 1 second interval. All right, that is the task. That the so the task here is to blink the LED once every 1 second. All right. Okay, that's it for this video. Now the link to the code that I use in this video is in the description. I hope you found this video useful, and see you in the next video. Bye.